So we still have 4 marbles, but now it's going to be red, 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 white. Now in this case, we have, the answer is 4. It could be red, 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 white, red, red, white, red, red, white, red, red, and white, red, red, red. But what we want to know is, why is it 4? And I wanted to kind of do it in the other way of doing it. So what we could see though, is that let's take the first one. We have the 3 reds, but there's, of the 24 combinations, there are 6 of them that are going to look like that. There's 6. Okay, I'm obviously not going to fit all of them in because I've run out of paper space, but we'll get the idea. It could be red 1, red 2, red 3 white, or red 1, red 3, red 2 white, or red 2, red 1, red 3 white, red 2, red 3, red 1 white, and 2 others. So essentially there's 6 ways of organizing the red. So there's going to be 6 orders that all look exactly the same. So when we're working it out, it's going to be 24 divided by 6, which is 4. Or another way of writing that, it would be 4 factorial, and there's the 3 r's are the same, and there's 3 factorial ways of doing that. And that'd be 4 factorial over 3 factorial, which is the 24 over 6, which is the 4. And that essentially, you should get an idea of where we're going with this now. So let's say we have 5 of them. So we're going to have G. Let's say we have red, 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 green, white. So now we have 5 marbles. So normally there would be, so it's 5 marbles, normally there would be 5 factorial ways of arranging the 5 marbles. But those 3 are the same, which means we could divide these up into chunks of 6. So it's going to be 5 factorial over 3 factorial, which is 120 over 6, which is 20 ways. Now let's say we had 2 red marbles, 2 white marbles, and a green marble. So the 5 marbles, if they were all different, would have 5 factorial ways of lining them up. But these 2 reds are the same, so we could divide it in half. And these 2 whites are the same, so we could also do that. And that's going to be 120 on 2 times 2. You have to be careful when you type this into the calculator. If you type in 120 divided by 2 times 2, you're going to get the wrong answer. So it's going to be 120 divided by 2 times 2, which if you did it correctly would be 120 divided by 4, which is 30. And let's do I. So let's say we had red, red, white, white, white. You can try this one yourself. Pause the video and do it. I'm going to move on. So there's 5 factorial ways of lining them up. There's 2 factorial ways of organizing the reds. 3 factorial ways of arranging the W's that all look the same. So that's going to be 120 over 2 times 6. 120 divided by 12. So there's 10 different ways of arranging 2 reds and 3 white marbles. Sometimes it's not always going to be marbles, of course. So let's change the question. So we may say, how many words in air quotes, of course, can be made with the letters. So let's say the letters are A, B, B, C, C, C. So how many words can be made with the letters A, A, B, B, C, C, C? Now I'm not actually asking for real words here, I'm asking for essentially arrangements of letters. And we're assuming we're using all the letters. So that's going to be A, A, B, B, C, C, C. There's 1, 2, 3, 4, 5, 6, 7. So there's normally 7 factorial ways. If they were all different letters, it would be 7 factorial. However, there's 2 A's that are identical. So that'd be 2 factorial. And B's, 2 factorial. And 3 C's, 3 factorial. And if you plug that in correctly, you would get 210. And there'd be 210 different ways. There's a formula for this. So the formula, let's see, formula. I don't think you really need to know the formula, but sometimes it's good to have formulas to kind of remember it. Let's say you have n objects. And you have A of one type. And B identical ones of another type. And C of yet another type. Etc., etc. Then the number of unique permutations, or the number of unique orders, so the number of unique permutations or orders is going to be n factorial divided by A factorial, B factorial, C factorial, and 3 dots, which is the math term for etc., etc. And this is the formula for permutations with identical, some identical items. As a challenge, it's not really part of the lesson, I'm going to just throw it in there for fun. How many 4-letter words can be made with the letters AA, BB, CCC. So it's kind of like the last question. The last question that we were using all the letters. And this is a challenge. This is a challenge. Try to figure it out. Maybe post your answer in the comments. There we go. It's a challenge.